Hello friends, here comes the very interesting topic of thermodynamics, that is free expansion. What do you know about free expansion? What exactly is free expansion? Everywhere it is written that free expansion is basically expansion of gas against vacuum. That means to say that there is no work involved in free expansion process. Is it so? If you have some objective questions in front of you saying that the work transfer is equal to zero in free expansion, have you ever guessed that why word transfer is exactly zero? Because the volume is changing? Right. So we will discuss this in detail about free expansion, and there are other parameters involved in it about free expansion. Sometimes you will be facing some difficult numericals related to free expansion. Sometimes in free expansion word transfer is termed as zero, and sometimes the word transfer is calculated as positive or negative. So what exactly it is? And there is some very interesting facts about free expansion, that the initial temperature is equal to final temperature. Initial internal energy is equal to final internal energy. Since temperature is same but the process is not isothermal, we know that the isothermal process is a constant temperature process. Here also the temperature is same, initial and final, but it is not an isothermal process. So there are some very interesting facts, very interesting statements about free expansion, and you will find those facts in the previous year questions of GATE and Indian Engineering Services. So this particular lesson is very important. Just go through this lesson at least twice or thrice so that you would not be facing any problem. But before proceeding any further, I would like to introduce myself. My name is Harshit Agarwal, graduated from NIT Nagpur in 2008. I have cleared the Indian Engineering Service Examination and GATE examination, got the offer letter from most of the Maharatna and Navratna companies. You can always rate, review, recommend, and share this course. It would be really beneficial for me and for an academy team. Right? You can do that a bit for all of us. If you like this particular lesson, fine. And you can always follow me on the specified link. So to start with, what is free expansion? The expansion of a gas against vacuum. There is some sort of vacuum. The expansion of gas against vacuum is known as free expansion. In free expansion, the work transfer is equal to zero. Because the gas is expanding against vacuum, there is zero resistance against expansion, and hence the work transfer is zero. See, in this is the figure, in this particular figure, this part is containing gas and this part is vacuum. This is the partition, and this is the boundary which is adiabatic. I mean, no heat is coming from outside. This is the adiabatic boundary, right? Inside this particular part is gas, this particular part is vacuum. This is the partition. The moment the partition is removed, the gas will occupy this particular space. Since there is no resistance against since there is no resistance, so work transfer is equal to zero. You know that work can be calculated if there is some sort of resistance, then only you can calculate the work. The moment this partition will be removed, the gas will fill this particular vacuum. This is the vacuum, so there is no resistance to the gas, so the work transfer is equal to zero. So the expansion of gas against vacuum is known as free expansion. In free expansion, the work transfer is equal to zero. In free expansion, the work transfer is equal to zero because as the gas is expanding against vacuum, there is zero resistance against expansion, and hence work transfer is equal to zero. Right? You can go through this statement now, but the volume is changing. Initially the volume is this much, and if the gas will fill this entire, the volume will come out to be this. So as the volume is changes, we can calculate the work transfer from integral pdv, and it would not be zero. So why work transfer is zero, we will see that. See, though in free expansion PdV is not equal to 0, the value of PdV, because dV is not equal to 0, work transfer is equal to 0. See, I have already told you W equal to PdV is valid only for a reversible process, reversible process, reversible process. But free expansion is a highly irreversible process. W equal to PdV is not valid for a free expansion process, because free expansion process is a highly free expansion process is an irreversible process, and hence PdV is not applicable. PDV is not applicable for a free expansion process. Just keep in mind, that's why work transfer is equal to 0. Now it is adiabatic, no energy interaction from outside or inside, so dq is equal to du plus dw. This equation is the first law of thermodynamic equation. dq is equal to 0, dw is equal to 0, that means du is equal to 0. So final internal energy minus initial internal energy is equal to 0, that means final internal energy is equal to initial internal energy. For ideal gas, as all I have already told you, for ideal gas, internal energy is a function of temperature. That means final temperature is equal to initial temperature. Again, from first law of thermodynamics, dq is equal to du plus dw. No heat interaction is taking place. dq is equal to 0. Work transfer, we have told you, dw is equal to 0. That means dq is equal to 0, dw is equal to 0, du is equal to 0. Final internal energy minus initial internal energy is equal to 0. That means final internal energy is equal to initial internal energy. And for ideal gas, we know that internal energy is a function of temperature only. That means final temperature is equal to initial temperature. So can we call free expansion as an isothermal process? Just think a bit. Can we call free expansion process isothermal process? No. Free expansion process is not an isothermal process. We will discuss this, but before proceeding, we just go through this particular part. We can also write this, use this particular P1 V1 minus P2 V2 for numerical point of view, because temperature, initial temperature is equal to final temperature. So why this is not an isothermal process? This is not an isothermal process because during the process the temperature is changing, but final temperature is equal to initial temperature. See, no internal energy change from initial to final. Initially the energy of molecules converted into kinetic energy, and last kinetic energy is converted into internal energy. Since from initial internal energy there is some change in internal energy, but at last final internal energy is equal to initial internal energy, thus net effect remains same. Similarly, though in free expansion of an ideal gas, initial temperature is equal to final temperature, initial temperature is equal to final temperature, the process is not an isothermal, but this process is not an isothermal process because during the process the temperature is not constant. What is an isothermal process? Isothermal process is a process in which throughout the process the temperature is constant. Throughout the process temperature should be constant, a horizontal line on TS diagram. But in this particular case only the initial and final temperature is same. जब ये process हो रहा था तो temperature change हो रहा था, लेकिन इनिशियल और फाइनल पॉइंट सेम है. लेकिन आइसोथर्मल प्रोसेस क्या होता है जिसमें थ्रू आउट टेम्परेचर कांस्टेंट रहता है. सो दिस इज नॉट एन आइसोथर्मल प्रोसेस, बट इनिशियल टेम्परेचर इज इक्वल टू फाइनल टेम्परेचर. सो इंपॉर्टेंट रिजल्ट, वर्क ट्रांसफर इज इक्वल टू 0. फ्री एक्सपेंशन इज अ हाईली इरिवर्सिबल प्रोसेस. इनिशियल इंटरनल एनर्जी इज इक्वल टू फाइनल इंटरनल एनर्जी. इनिशियल टेम्परेचर इज इक्वल टू फाइनल टेम्परेचर. So we will discuss this in detail with the help of beautiful numerical. Just go through this numerical so that if you will facing any sort of problem, you can clarify that problem with this numerical. The question says, when the valve of an evacuated bottle, this is an evacuated bottle and this is the valve, often is opened. Whenever the valve is opened, atmospheric air rushes into it. This is the atmospheric air which rush into the bottle. Atmospheric pressure is taken as 101.325 kilopascal. Atmospheric air is taken as 101.325 kilopascal, and 0.6 meter cube of air enters into it. In this 0.6 meter cube of air enters. This is the evacuated bottle. This is the atmospheric air. In this 0.6 meter cube of atmospheric air enters into the bottle. Calculate the work done by the air. We have to calculate the work done by the air. See, the bottle is evacuated. The moment air rushes into it, it is can it be a free expansion process? Just think. So there are different cases when outside air is taken as system. If this is the air is taken as system, so work done would be P naught V. Work done by the system is taken as positive. Outside air is taken as system. This air is coming inside this bottle, so P naught into volume, this is the work done by the system, positive 60.79 kilojoule. When the system is taken as this, when the system is taken as bottle, outside air is entering into the bottle, that is work done is on the system. On the system it is minus 60.79. When outside air is taken as system, it is work done by the system. When bottle is taken as system, then his work is done on the system, which is minus 60.79. So where is the case of free expansion now? Where is the case of free expansion? Just tell me. Free expansion is when you will take this bottle and outside air completely as a system. When outside air and inside system both are taken as system, then it is the case of free expansion. See, in free expansion, we have taken this whole as a system, this part as well as this part, and moment the partition is removed, this air will fill this volume. That's why the work transfer is equal to 0. Similarly, in this particular case, this system and this system, we are taking total as a system. So the moment the valve is opened, the partition is removed, the valve is open, the outside air will fill this evacuated bottle and the work is equal to 0. So if only the outside air is taken as a system, the work is positive. If inside bottle is taken as the system, the work is negative, that is on the system. If you will take this complete as a system, the net work is equal to 0. Right? Just simply go through this numerical. In exam, just read the question carefully what has been asked, whether work done by the air, work done on the bottle, or it is a case of free expansion. The case of free expansion is like the bottle and the outside air both is taken as system. I think it is clear to you all, right? If you have any queries, you can ask me. So the important results of free expansion is it is an irreversible process. Work transfer is equal to 0. Initial internal energy is equal to final internal energy. Initial temperature is equal to final temperature. And this is a very important numerical. You can just go through this numerical. All your doubts would be cleared. You will feel really confident in this particular subject of thermodynamics. I am pretty much sure about it. Thanks a lot from my side. This is Harshit Agarwal. Thank you all.